is a weak magnetic field, which is used in many medical diagnostics. It's a dipole field, and it's produced by a current loop in the outer layers of the heart. So let's think for a moment, what does that look like? So here's our heart, and it says that we get a current loop in the outer layers of the heart. So the current comes around something like this. That floating current makes a magnetic field. What's the direction at the center? Well, our thumb goes with the current, and our curled fingers show that that magnetic field comes right up out of the center. So there's the direction of the magnetic field B, due to the current in the outer layers I. Our first question says, if the field at the center of the heart is 90 picoteslas, so if the strength of the magnetic field is 90 times 10 to the minus 12 teslas, how much current do we have to have if the diameter of the heart is 8 centimeters or 0.08 meters? Okay, so let's think about what we have here. If we wanted to figure out an expression for the magnetic field as a function of the current, we would use our Biot-Savart Law. So the strength of the magnetic field would be the integral of mu naught I over 4 pi times the magnitude of ds cross r hat over r squared. ds is a little bit along our wire, so ds comes along this way. R is a vector that goes from ds to the center of the heart. So r hat goes towards the center. So in our magnitude of our cross product here, we get the magnitude of ds times the magnitude of r hat times the sine of the angle between them. Since ds is tangent to the circle and r is towards the center, those two guys are perpendicular, so the angle must be 90. That's divided by r squared. So that's the same as mu naught times I times ds over 4 pi r squared. So here the magnitude of ds is the size ds. Magnitude of a unit vector is 1. Sine of 90 is 1. The reason it's 90 is because the tangent is perpendicular to the radius. So that's where everything is coming from there. We can take all of our constants in our integral out front. Mu naught I over 4 pi r squared times the integral of ds. The integral of ds is the distance around our loop. That's just the circumference, 2 pi r. So that means that the magnitude of our magnetic field B is equal to mu naught times I times 2 pi r over 4 pi r squared. Pi's cancel, one of those r's is gone, 2 goes into the 4 to give 2. So now we have an expression we can use to calculate the current I. I is going to be 2 times r times the strength of the magnetic field divided by mu naught. So 2 times 0.0, careful here, the diameter is 8 centimeters, so the radius is 4 centimeters. The size of the magnetic field, that was our 90 picoteslas. We divide the whole thing by mu naught, which is 4 pi times 10 to the minus 7 teslas meters over amps. That gives us a current of 1.15 times 10 to the minus 5 amps. Or amps, yes, amps for current. Okay, so that is a pretty tiny current, but then it's your heart. You don't want a whole lot of current going through it. There's part A. Part B, what is the magnitude of the heart's magnetic dipole moment? Let's remember how we find a magnetic dipole moment. The size of the magnetic dipole moment would be the size of the current times the size of the area. So current times pi times r squared. We can put in our current that we found above times pi times the radius, 0.04 meters squared. And we get our magnetic dipole moment, 5.78 times 10 to the minus 8 amps times meters squared. So there's a little bit about the magnetic field of the heart.